Hello students, today class is design of two-way slab by working stress method. The problem is given, that is room dimension is given, support thickness is given, and materials grade is given. Okay, so as I told earlier, first you have to uh, write the permissible stresses of materials, that is FCK 20 Newton per mm square. For that, sigma CBC value is 7 Newton per mm square and Fy equal to 415 Newton per mm square. For that, sigma ST value is 230 Newton per mm square because of this is Fe 415 steel grade. Okay. The first step is slenderness ratio. That is, it is the ratio between longer span to the shorter span, which is less than 2. Okay. If it is greater than 2, you will go for design as one-way slab. But here, that value is less than 2. So therefore, design as two-way slab. Okay. So next step is dimension, thickness of roof slab or depth of slab. It is obtained from IS 456 for simply supported the span by depth ratio equal to um, 35 into zero point 0.8 because it is a two-way slab as per codal provision page number 39. uh, you write very carefully, or we read very carefully. That is mentioned as the L by D basic value as 35 into zero point 0.8 for deformed bars. Therefore, the effective depth uh, value is 0.142 meter. The overall depth is add it to the effective cover, that is this is slab, therefore effective cover as 25 mm, therefore overall depth equal to 0.167 meter. Okay, so next step is load calculation. So in slab, so the following loads uh, uh, have to be acted on it. The first one is self weight, second one is slide load, then floor finish. Okay, the self weight of slab, it is obtained for kilonewton per meter. Okay, therefore unit weight of RCC into, so slab design means so you have to design in 1 meter width, therefore B equal to 1 meter, therefore multiplied by 1 into overall depth 0.167 meter, therefore self height of slab equal to 4.175 kilonewton per meter. Then lie load is given 2 kilonewton per meter. Floor finish is assumed as 1.75 to 1. You can assume as 0.75 to 1 kilonewton per meter. Therefore, total load equal to 7.175 kilonewton meter. Okay. Then effective span. Effective span means Lx. Okay. Here Ly and Lx values are given, but the effective span shows that Lx value. Okay. So Lx equal to, so least of clear span plus effective depth or center to center support distance. Okay, so here the least value is 4.142 meter, that is clear span plus effective depth. Then next step, according to codal provision IS 456 page number 91, you have to calculate, or you have to determine two bending moment along x direction, sorry, along shorter direction and along longer direction. That the formulas are given in IS 456 page number 91. That is mx equal to alpha x WLX square, then my equal to alpha y WLX square. Okay, so so Lx square. Okay, not Ly, it is Lx. Lx alpha x and alpha y, yeah, which are given in IS 456 page number 91 table 27. Okay, so in your problem, read very carefully. So without any provision for torsion. Okay, so that you can go for table 27. Okay, table 27, the alpha x alpha y values are read out. So mx equal to 10.893 kilonewton per meter, my equal to 7.016 kilonewton per meter. That shear force value WL by 2, L means Lx. Therefore, V equal to 14.859 kilonewton. Okay. The next value, next step is check for effective depth. Okay. So because the slab depth is assumed, so that's why we have to check effective depth accordingly. So small d equal to root of mx divided by qb. So here m means maximum moment. So here mx value is maximum. Therefore, apply mx value in this formula. So small d equal to 110,015 mm. So required depth which is less than provided d. If it is greater than d, if it is required depth is greater than provided d, you should it should be redesigned. Okay, it should be redesigned, or you have to change the dimension of slab. That means depth of the slab. Okay, so next step is once moment value is arrived, you can go for reinforcement detailing step. That is main reinforcement. So you have to find the AST along x direction, sorry, along shorter direction and along longer direction, because both reinforcement are acted as main reinforcement in two-way slab. Uh, but in one-way slab, along shorter direction only act as main reinforcement. Then transverse reinforcement act as distributor. Please keep in mind. Okay, so ASTX equal to 3 required ASTX equal to 370.586 mm square. Okay, according to SP16, practically in slab you can prefer main reinforcement diameter as 10 mm, then distributor diameter as 8 mm. Okay, so uh, in two-way slab, both reinforcement, as I said earlier, both reinforcement acted as main reinforcement, but you need not provide a 10 mm dia for both reinforcement. Okay, only you can prefer, only you can provide 10 mm dia in shorter direction only. Okay, uh, in longer direction, if it is uh, uh, main reinforcement, uh, you can provide atom dia also. Okay, therefore main reinforcement for shorter direction 10 mm dia, 220 center to center. At the same time, ASTY equal to, that means AST longer direction equal to 238.688 mm square. Okay, so here also uh, we preferred 10 mm dia, but in practically you can go for 8 mm dia only for longer direction. But the, it is nothing else. Nothing else. Okay. Mm. Then check for shear. Check for shear. So you have to find the nominal shear stress and the permissible stresses and compare both values. So in slab, permissible shear stress multiplied by the modification factor. So modification factor, which is depending upon the depth of the slab. If slab thickness greater than 0.15, then k value is 1 according to IS4 filter. Here is tau v less than tau c into k and save. So according to slab, the shear will be very less. uh, so you have to concentrate on deflection check only. Okay, so L by D actual, the condition is L by D actual is less than L by D max. So apply those things. L by D actual equal to 29.169, L by D max equal to uh, L by D basic value for two-way slab 35. okay, uh, which I already found, that is basic value, okay, 35, and the kt value is calculated based on fs and the design curves. So fs value 238.5 newton per mm square, so t equal to 1.55. Okay, kc kf both values are as 1, so l by d max equal to 54.25, therefore l by d actual which is less than l by d max, so and save. So the reinforcement uh, uh, of a slab uh, lies slide is given. Okay, so both main reinforcement will be bent up. So in alternative uh, reinforcement bar. Okay, so the reinforcement detailings are given like that. You have to provide in site also. Okay, thank you.